All right. Okay, for today's program, we're going to talk about some of the factors for weight loss. And it's interesting because there's some research that came out. And before we get into that, we're going to go into some of the research that came out this week regarding factors for weight loss. And we're going to talk about another one where, and there's a lot of information on this. And I've been talking about this for a long time. And I really don't think that science still gets it or understands it. And of course, they're always looking for a medication where we can interrupt something with our biochemistry. And it's really not about the medications. It's about finding an answer that's going to balance this. So I want to remind everybody, we do stream live at facebook.com/NutriMost USA. And we do this every Saturday at 9 a.m. to 10 a.m. That is a hard time because we're simultaneously broadcasting with KDKA. The Thursday program is at 12 noon every once in a while because I do this, I work and do this right after. We sometimes have to start just a hair late, but we're always pretty close to that time period. And it's always about the same thing, how NutriMost and how you can create your most beautiful, healthy life. And we take a look at the most significant research and news. And I'll either take things that are really in the news, or we'll take something and we'll look at what is going on, just some of the things that can help you. But let's just take a look at something that's been in the news. And let me just get this on here so we can, let's see if I can show this. Okay, we're going to go, there's two different things that I want to talk about. This is from the British Medical Journal, and it's about, as you can see, effects of changes in eating speed on obesity in patients with diabetes, a secondary analysis of longitudinal health checkup data. Let me just explain what this study is about. And this was an observational study, and I'll tell you what, observational studies are getting a lot more traction today, and the reason is they're real life. It's you take a look at what people are doing, what works, what hasn't worked. Let me move this in just a little bit closer. Okay. What works, what hasn't worked. And what they found out is that when you slow down how fast you eat, you end up decreasing your risk of obesity dramatically. In fact, here's what they've shown, that when you take a look at people who just basically eat at normal speed to people who just gobble down their food, those who eat at a normal speed are 29% less likely to be obese. But when you take a look at people who eat slowly, not just normal speed, but eat slowly, that number rises to, they have a 42% less risk of obesity. But they also showed that if you cut out snacks after dinner, if you don't eat within 2 hours of going to sleep, and by the way, I talked about this last week, and there's reasons for that, and it's all about, and I talked about the circadian cycle, and I encourage you, go back and look at that about the circadian rhythm. But the closer that you get when melatonin goes high and you're eating during that period of time, obesity rates go through the roof. You know, they compared eating a large breakfast versus eating a large dinner. And it's really not whether it's breakfast or dinner. It's really just comes down to, I challenge, and what they do is they had the same number of calories for the total, but they would change where you ate those calories. Well, the closer that you get towards the nighttime, the more that your risk of obesity goes up. And that has to do with your circadian rhythm. And so what we want to do, and that's why we say the largest meal really should be at lunchtime. And there's reasons for that. But it's also because of the fact if you start to bring in especially carbohydrates, especially if you start doing snacks at night, now you're really going to have some real issues. And because it actually it interrupts leptin as well. And what they found out is that people who, and they also looked at whether you eat a big breakfast or you skip a breakfast, and they found out that didn't really have as much to do with it. And that's why I've been saying, you know, I talk about the fact, and I would challenge that a little bit, because I would say that the body acts differently. It acts differently with the biochemistry when you don't eat versus if you eat a sugary food at breakfast, which so many Americans do. And it's not, and what happens is it sets up your leptin pathways. It sets up your AMP, activated protein kinase pathways, and it makes that different. So those are, that was a big thing with this. I also want to go to, there is another study came out this week. At least they published it online this week. This was, and let's see if we can bring that up here. Here it is. This is, and on this is the AGRP. What that is that's the agglutinin-related peptide neurons. And these are neurons that are found in the hypothalamus. And you know, it's interesting because you'll hear people talk about the paraventricular nucleus. You'll hear people talk about the arcuate nucleus of the hypothalamus. You'll hear people talk about the suprachiasmatic nucleus of the hypothalamus. The hypothalamus is so involved in regulating energy. And what this article is about is, you see where it says here, let's see if we can highlight that at all. Right here it says highlights the CRAT in AGRP. Let's see if I can, does that highlight there? There. CRAT in AGRP neurons help nutrient replenishment as food is available after fasting. Here's what this whole thing is about. This is about whether you can fast if you're dieting. They're talking about the fact that when you diet, that after you diet, that there is a switch that, and we all have seen this. You know, everybody talks about this. That one of the things is this yo-yo dieting. That when you decrease your food, your body goes into this starvation mode. And that starvation mode then turns fat burning off, fat storage on. And it's really to protect us when there was in times of famines. But today, with that not particularly being the case, particularly in the United States, we see that that's a very, the use of that is not where it used to be. So today, what they find out is there is a particular protein that has been identified, and that protein is carnitine acetyltransferase. And carnitine acetyltransferase, or CRAT, which is what was on there when they say, that is part of the hunger processing that occurs, that when you have a famine, basically it's all about regulating these CRAT enzymes. And here's basically what it says. And they said this is the first time the CRAT protein in these processing cells, these agglutinin-related peptide neurons in the brain, that they showed that, first of all, they identified that that's the switch that tells the body to go from one into the other. And they said, and what this comes down is that if you manipulate these, that you can trick the brain, and that can affect this. See, here's the thing, but we know that there's, and by the way, the agglutinin-related peptides, they have been studied for so long, and they're mainly involved with hunger. Except, see, the thing about this is, and this has been, you know, I can tell you this, what we've known before, that when you fast, that these agouti-related peptides, they actually become, particularly at the hypothalamus, they go into a state of autophagy. And autophagy is a regular house cleaning of basically of how the body takes out bad cells and replaces it with healthy cells. Autophagy means self-eating. And what they found is that as you would eat this, in other words, as autophagy increased, and it would break down these agglutinin-related peptides, neurons, and as you broke that down, it would release some fatty acids, and these free fatty acids would go into the body. And what they found out is that would stimulate and regulate this the hunger, so that when you had an increase, and it would trigger the agglutinin-related peptides themselves. So we're talking about the neurons, and we're talking about the peptides. So what happens with autophagy, see, when you don't eat, the gluten-related peptide, these hunger neurons, these hunger-related neurons that are in the brain, they start eating themselves. And so in that act of eating themselves would actually stimulate the body to produce more hunger. And it looks like that's the way that it was regulating. And they talk about this fact that when the lipids would break down, create more free fatty acids, that would in turn boost the AGRP. And AGRP is a signaling protein itself. That's why it's been talked about that, and that occurs in the hypothalamus. So the hypothalamus really is what regulates that. Well, now scientists today have discovered something. They discovered this CRAT, which is this carnitine acetyltransferase, that's what's involved in increasing the gluten-related peptides. That's what's responsible for producing this in the brain. Here's the thing. What we do know is that, and when we look at they've been trying to find out what's the root of hunger, because we know that there's tanocytes, which are these special neurons that have these long strands that reach basically deep into different areas of the brain, and they're stimulated by certain proteins that we know that has been shown to have some effects on hunger. And in fact, there are certain proteins that when we eat, those proteins, what they do is they suppress hunger. So we have these hunger-inducing neurons that basically activate an area of the brain that it's interesting because there's certain areas like the paraventricular nucleus that's associated when you're full, when it's satiety. And yet they find out that these neurons actually affect that area. They affect the area that makes you eat, and that would be the arcuate nucleus. They affect an area that controls your energy expenditure, which is the leptin, and that is the suprachiasmatic nucleus. And the suprachiasmatic nucleus is more for, I would say that it would be more with the circadian rhythm, and that's what we talked about earlier. So here's the thing. When you have high AMPK activity, those levels also increase firing of the hunger neurons. And so what is the higher AMPK activity? That's what we want when we're on a diet. So here's the thing. And you'll hear people talk about, and that's what this study that just came out. Let me just see, and let's just go to that study. We look at this study, it's that these gluten-related peptide neurons require the carnitine acetyltransferase to regulate the metabolic flexibility and peripheral nutrient partitioning. A lot of words that basically just say that that when you diet, that they make you hungrier. But there's other aspects to that, and that's what that's the whole trick. That's what we've been trying to do with NutriMost. Is we say, okay, we know FGF21, for instance, has a tremendous response on metabolism. We know that leptin has a tremendous response on metabolism. What happens is when that breaks, that's where there's a problem. I'll give you a perfect example. I talked about how the free fatty acids, that when you have autophagy with the AGRP, these AGRP neurons, as autophagy increases, it breaks those down. That increases free fatty acids. Those free fatty acids then increase the gluten-related peptides themselves. That increases hunger. Okay, if you eat more fatty foods on just a regular basis, especially when the body is leptin resistant, and so like just a regular high-fat American diet. We're talking about a regular high-fat diet. What we now know is that increases the free fatty acids. It basically gets the body into this increased hunger, and it breaks the energy metabolism. So now you have less energy expenditure and you have more hunger. And that's one of the things that happens. And what you break leptin. So how do we accomplish? What do we need to do? Like, how does this affect us on a day-to-day basis? Okay, we know that there are certain activities, as we saw earlier today, where eating slow, not eating near when your melatonin is high. There's so much more biochemistry than one item. There's another one that affected the gluten-related protein, and that was the FOXX01. And what they found out is that when that mice that lacked FOXX01, that's another protein, it had a profound effect. They found out that they would eat much less. They were leaner than normal mice. We find out that if you completely take out certain factors, you not only become leaner. And if I find that, one of the things is that if you can take out a gluten-related proteins, if you can just take these out, you actually will become anorexic if you completely don't have it. So you can see there's certain things, but again, these are all imbalances, and it's when the body is not functioning normal. So how do we relate this? See, everything we do in NutriMost, and this is one of the things that we've been working with for so long, that we continue to try to say, okay, we want to balance the body. Everything else is an imbalance. The number one thing that we have to do is if you're going to interfere with certain factors, there's certain things you can do. Every cell in cellular respiration has cellular exhaust. We know that when you get into fat burning, that cellular exhaust, as you increase activity, as you increase metabolism, you are increasing cellular exhaust. So there are certain factors that are a part of that. Just like our exhaust is, we take in oxygen, we breathe out carbon dioxide. If you didn't have any more oxygen, you're just having more, as that increases more and more and more, that's going to be a problem. So we need to eliminate those factors that are cellular exhaust, okay? And there's certain metabolites. And that's one of the things that we do on NutriMost, is we want to decrease certain metabolites. One of those, as you know, is the hydroxyl radical. That's one. The peroxynitrite radical. That's another one. Many of these reactive oxygen species. Now, you can't eliminate all of them, because there is also a feedback mechanism that they regulate some other factors. Now, the other thing that we need to do is we need to maintain and regain leptin. The first thing is regain leptin sensitivity, insulin sensitivity, FGF21 sensitivity. Those three control so much aspects of this. We have to be mindful that we can affect these centers by keeping our biochemistry regulated. We know that once you get into a full fat burning state, a state of ketosis, your hunger decreases because you're getting that energy. So if you're releasing energy in the form of ketosis or fat burning, that suppresses hunger. The research is plentiful out there. So it's getting into that optimal state. Now, once you're in that state, it's very easy. There's a lot of things that many factors come into play that can create, once you lose, to create this starvation mode. So how do we affect that? And that's where all of this comes in to play with the AGRP. That's where it comes in with the AMPK pathways. Whether you're in fat burning, AMPK is going to help you get into fat burning. But once you're in fat burning, and once you go through that can increase those AGRP neurons. So we want to affect that. And it's really about balancing the body, not just balancing when we talk about getting you leptin sensitive, so that because what does leptin do? Control, manage, and direct energy within the body. So it helps with it has a direct effect on your thyroid. It has a direct effect on your adrenals. It has a direct effect on fat burning. And what we see now is there is another protein, and that's with that FOXX01 protein. And what we see with FOXX01 is that if you can completely remove that protein, it makes it very lean. So what is that protein? Where is that? Well, that is a protein that's integral to insulin sensitivity. It's integral to leptin sensitivity. And that's why it's so critical to have leptin sensitivity. Now, how do you know if you're leptin sensitive and how do you know if you're not leptin sensitive? Well, when you're leptin sensitive, it's really interesting because when you're leptin sensitive, you dream better. When you're leptin sensitive, you're not hungry between meals because it knows that you were fed, you had a meal. And see, if you had enough to eat, then it knows that you don't have to. It's not like, hey, we got to replenish this. It's not like you're not eating. The other thing is you need to have the nutrient-dense food. You need to have absorption of your food, of your nutrients into the body. You have to have the amount of the balance of all of your nutrients. And that's one of the reasons why there's certain, we look at what is it that your body, what is your body's unique needs, your body's unique requirements that's going to help you. So you may be nutrient deficient. And it may be just, you can be so, you're eating and eating and eating. You have all these other, you can be really high on certain nutrients and very low on others. And again, you have to make it in a way that the body is designed for. And that is once living products that had DNA. So we know that. And these are things that you can, that's one of the reasons why we'll bring in certain nutrients to the body. There are certain things we need to do with that, as we talked about, cellular exhaust, so that doesn't build up too much. We want to time our foods based on the chemistry from that. We want to give foods that, we want to bring in foods that aren't going to alter chemistry and affect dopamine, certain dopamine levels. It's not going to affect the serotonin levels. It's not going to affect certain neurotransmitters that are going to be associated with creating these pathways that are going to want you to eat more food. So when you do it properly, and that's one of the reasons why there are certain foods that you can start bringing in. There are certain things that you can do once. If you start to gain, and that means you're starting to get out of leptin sensitivity. By the way, leptin sensitivity, you'll get the fat will start building up in the wrong places. You'll get that, for instance, that spare tire. You'll get the belly. You start to gain weight. That's one of the first things that you notice. You start to gain weight. Instead of you shouldn't just gain weight when you're not eating foods that are in excess. So when you start to bring in foods that are a typical normal amount, and you have to know what that amount is. There's a certain range, but you have to take it from a diet, take it to not on a diet anymore, that you're no longer on a diet, but you're maintaining that biochemistry. And it's really the science that allows us to take these things into account. And it's working with these areas of the brain, the suprachiasmatic nucleus, so the hypothalamus, the arcuate nucleus, the paraventricular nucleus, understanding. And the thing is, that's where, we try to look at NutriMost intelligence to say, hey, can we have any advantage on this as far as what are the different nutrients that your body may need? Is there an advantage on finding out what are the particular foods that your body will do best with and which foods do they not do as well with? And you look at that and you come up with these factors so that you're not blocking this signaling pathway, so you're not creating a problem. And by the way, we talk about the fact that so often it's not your fault. There are food engineers who are designing your food to try to break that pathway. They want that pathway. They want you to desire their food. They want you to want that food. And what we want to do is we want to give you the tools so that doesn't occur with you. And that's really such a huge factor with this. So I just want to say, let me bring back up our, what did I do there? One of the things, as we end this, and know that we're working really hard on the science. We're looking at the science every single day to say, okay, it's not, I understand. You want to work smarter and not harder. And that's what NutriMost is all about. And we want to use research that's going to make us work smarter and not harder. And understand that, yes, there are numerous factors. Yes, there are things that you can do to really help you create your most beautiful, healthy life, but help you more easily, that you're not fighting against your weight loss. It makes the weight loss easy, but not only make weight loss easy, but make it so that it's easy to keep the weight off. You'll hear people say permanent weight loss. And, here's the thing. If you go back to eating certain things, I can tell you, can't take anyone, and I know the ways that you can basically break the mechanisms. You can break that biochemistry so that you will become leptin resistant, and you'll know it because you will be hungry. You'll have you'll want to snack all day long. You'll want to have midnight snacks. You'll see weight gain on. You'll see that you'll hardly be eating anything, and you'll be able to, and you're just gaining weight. You'll see you're gaining weight abnormally in certain areas. You see certain things won't fit the same as they were. You'll notice it. You'll have less energy after you eat. You'll notice that you'll be very lethargic. You'll eat something and just be very lethargic afterwards. You want to go to sleep. In fact, you'll notice that you'll stop dreaming. You notice food just doesn't taste as well. It used to be like something would taste great, and not just doesn't taste. It all starts going together. Like nothing really has a great taste. You're eating for no real reason to eat. That's when you're leptin resistant. People always ask me, how do I know? That's how you know. When you're sensitive, man, it's just like you're just a machine. It doesn't seem like you need to eat. You can you eat your meals, and you're not hungry afterwards. You go to that next meal, you're not hungry, but you after the meal's done, you're not lethargic. You want to go out. You're ready. You're ready to take on the world. That's what it should be like. Okay, so today I hope you understood some of those factors. And as we, one of the things that we started this with, and we said, what are the things that you can do to, just some simple factors. That was one of the research. And what we found out is there's some really simple ones. Eat slower. That's such an easy thing to do. And when you see just the simple fact of eating slower makes just such a huge difference with this is really just amazing when you think about it. And so don't snack between meals, and do not eat towards before you go to bed, because that's when your melatonin is highest. It's paying attention to the circadian clock, and even worse than that would be eating at night when you're not supposed to be even up at all eating. And it's really just about balancing your neurotransmitters, balancing your biochemistry, getting your body on track. That's our goal, and let's put it to good work. And remember, it's all about creating your most beautiful, healthy life. Please do that, and I assure you I will do the same.